using UHF RFID Hemispherical dome. Let me introduce myself and my team. Summer Al-Madawi, Nada Khalid, Yasmin Zahrour, Monica Williams.
The main concept behind the proposed setup is to mimic the anechoic chamber using only commercially available low-cost components such as RFID tags, RFID reader, wood, plastic pipes, sponge, and fabric material with a laptop. The proposed system is based on the perception of providing a stationary measurement setup model. The model consists of a 3D sponge hemispherical dome mounted over a wooden tripod with equidistant RFID tags distributed. The antenna under test will be oriented facing the dome exactly at the center and connected to a programmable RFID reader. The reader is then connected to a PC for real-time output data handling via MATLAB. A set of plastic pipes are used to form a hemispherical dome. The sponge dome is then inserted into the pipes and then fully covered by a fabric material to form a self-holded dome. The dome is mounted vertically on the tripod in order to minimize indoor ground reflections. The next step is to distribute the RFID tags along the inner surface of the dome. Each tag now represents a unique observation points that correspond to a distinctive theta and phi. The illustrated tags arrangement is then rotated 90 degrees to assess the cross components of the antenna fields. The stationary antenna shall be facing the center of the dome. You can easily flip the antenna in order to be able to measure the back lobe half-space observation points. The measurement process starts with the antenna excitation and radiation through the reader sending procedure. The power encountered by the passive RFID tags due to the antenna radiation guides back the unique tag ID, frequency of response, and the received signal strength indication to the reader. The measurement setup is repeated for different antennas in terms of frequency of response, bandwidth, and polarization. This happens to validate the proposed system capabilities. A graphical user interface is then developed to ease the results illustration. The output data files are accessible using the GUI and the results are displayed in a simple educational panel. To be stated, there is an agreement between the dome measurements and the anechoic chamber measurements for this tested wideband antenna. The system setup is based on commercially available components where no mechanical or electronical rotation is required. The system was successful in realizing polarization, frequency of operation, gain and S parameters, as well as constructing a 3D pattern of the antenna.